Okay, class. So today we come to section 3.4, application to finance. We come up with a question saying, would you rather have $1,000 right now, or you're gonna have like 1,500 in 10 years? So you can take it right now, or maybe later, 10 years later, you get like 50%. And you're gonna say that, sorry, I'm gonna say that 500 extra, right? So this is $500 extra, with actually like 50% increase from initial value, right? So we're gonna try to explore the relationship between the present value or initial values and the future values. Now let's start with simple interest first, right? In this session, we're gonna talk about simple interest, we're gonna talk about compound interest, and also we talk about continuous compound interest. So simple interest, let's talk about it first. Simple interest is what? It's just very simple changings. It's just like constantly adding an amount of money. From that amount of money. So why I say this? Because it looks like, for example, even though it's by rate, but it's the rate it just applied for only one time, like from the initial time. And that's rate just apply only for the first initial time. So it's make only constant changings forever. Okay, so we have formulas at A equal to P times 1 plus RT, right? And A is future amount, like in the future, what do you get? Okay. P is the present value, like right now, amount right now. And R is the rate. And this could be written as decimal. Keep in mind that this is generally in the interest rate. And lastly, we have T as duration of loan, and it's 1 ride in year. Okay, so keep in mind that if it's in month, we need to convert into years. 6 months, for example, then we have to convert it into 0.5 years. Okay. All right, so now let's start with example 3.16. All right, Linda loans Bernie $1,000 for 1 year at 5% simple interest. So how much money will Bernie have to pay Linda at the end of the year? So this clearly that given us the word simple. Okay, or I mean, if they even don't have the word symbols, right? And just say like 5% interest, then we can just apply the formula as simple interest. Okay, so now they say at the end of the year, that means just for 1 year, right? And also in the given here, just for 1 year. So right away we can have in here is in order to find the amounts, you can start with $1,000 at first, right? You adding with maybe I'm gonna write as like present amount plus with interest amount. Right. So amount to pay after 1 year. Okay. So I will have present amount is amount that she just start borrow, and she's had to adding with the interest amount. What is the interest amount? You have to multiply 5% is 0.05, and it multiply with the amount she did borrow, right? So then you will have 1,000 plus with 50, and that's give us as 1,005 50 I mean $50, right? Yeah. So that means she had to return Linda at the end of this year is $1,050, right? So what if Bernie need 1.5 years in order to pay off the loan? And how much will the payback be? So so in this case, I will just apply the formulas here and get, say, A will equal to P times 1 plus RT. Okay, keep in mind that we have R in here is 5%, is 0.05. P in here is what? 1,000. T in here is what? 1 year, 1.5 years for the second case. All right. So then we can just substitute 1,000 time with 1 plus 0.05 time with 1.5. So you can have 1,000 times with 1.075. Would give us as $1,075. Okay. So that is the that's the way we calculate for the simple interest. Then we make conclusions as if P is the present values and A is future values, Linda is willing to trade $1,000 today for $1,050 in the future after 1 year, right? And Bernie is willing to trade $1,050 $50 in the future to having thousands in the present today. I mean, I would move this before the 1.5, right? Okay. Use the red color. All right, so now it is standard in business for interest rate R to be written as decimals and the time of the loan T to be given in terms of years. So we need this note, maybe I can say note, right? That's rate is always in decimal and time is always in years. Okay, so we don't mess up with unit. Okay, all right, now let's practice with the next examples. So we have Felix borrows $2,500 at an annual rate. Annual rate is yearly rate, so just keep in mind that 8%. And for the period of 15 months, and we want to use simple interest formula to compute. Okay, so listing, what is A in here gonna be? Do I have? No. So put question marks, right? What are P? Do I have? Present values is because Felix borrowed $2,500. So it is a present values. That's Felix borrows. And what's the rate? 8%. So is 0.08. What is T? 15 months. I have to convert it in year. How can I convert 15 months in year? If it is in month, you divide by 12 months, because once you have 12, right? So you have 15 divided by 12. So 15 divided by 12, what is that equal to? You can use calculators. Let me use a calculator. 15 divided by 12. I have 1.25 years. Right. Okay. Now I just substitute everything in. So I have 2,500 and a time with 1 plus the rate. It's 8%. Oh, wait, 0.8 because I want it in decimals. And a time with T, 1.25 in years. And you can use calculators to find it. Right. I got 2,750. So this is the amount that he has to pay back. Okay. All right. So I would like to review these problems 3.16 and try to handle that with the way I just show you. And the key would be 1,242. Okay. All right. Okay, make sure change the rate into decimal, change the year into change the time into year, right? So similarly for 3.17 gonna be 1900s. Answer key. Actually I'm gonna show you to 3.17. Okay, so let's read this first. Raul loans his friend Peter some money at an annual rate 5%. So we have rate is 5%, 0.05, right? For 18 months, so 18 months change to be 18 divided by 12. What is that equal to? Gonna be 1.5. Right. What else? At the end of 18 months, Peter paid off the loan by giving. Okay, so watch out this, right? Giving Raul 2042.50 cents. So this say at the end of 18 months. That means like, is this the present value or is this the future value? Think about it, right? It should be the future value. So A in here must be equal to 2042.50, right? P values, you don't know. Good question mark, right? So for this kind of problems, we will go ahead and just keep just using the simple interest formulas because we are using the simple interest right now, right? Keep in mind that even though in here I don't say the word simple interest, I just say annual rate gonna be this, right? But you still have to use the formula of simple interest. Okay, if I don't say anything like compound interest or some word with compound, then you must use simple interest. Okay, so now substitution. So I'm going to say substitute with all the values. I'm going to have A is 2042.50 will be equal to P, because you don't know, time with 1 plus 0.05 time with T, which is 1.5. All right. Maybe we'll simplify a little bit, maybe, right? So we're gonna have 2042.50 equal to P. Okay, so the inside there, 1 plus 0.05 times 1.5. Use calculators, you're gonna get 1.075, right? And then you want to fight for B, right? Just divide both sides by 1.075. 2042.5 divided by 1.075. You got P, right? So what is the P gonna be? Double check. 1900s. As I giving you here, right? Okay. So note that Note that. Sometimes we are not given the so Mrs. Maybe we are given the future amount future values instead of the present value. But we can substitute all the value into the formulas and solve for the unknown value. So, yeah. That could be it. Okay, so nouns. I would love to let you guys do exercise 3.18 and keep my last. You are given the p value, right? P value equal 10,000, and you are given rate is 4%, width in 0.04, right? And for part A, you have t equal to 1 year, which is 1. B, you're gonna have t equal to 5 years. So keep like that. And then you will find for A, what is that, right? And then you're gonna find for A for each case, right? Okay. So I don't wanna give you the skip this. Go and try. We moving to the next topics of this interest. Okay, so next things is I'm gonna talk about compound. So I'm pretty sure that if you have loan or borrows money from the bank, and you maybe come to the bank sometime and see this word compound interest, right? So so let's say suppose you deposit $100 into an account with 5% compound annually. So 10 years later, how much you have to pay? So if you using simple interest, it's just gonna be basically gonna be like $100 adding with the 10-year interest, right? However, this is the case that's kind of different with simple interest. Is keep adding interest and the initial amount from previous year to the next initial amount. So let me show you what happened. Okay, so this is starting amounts. So starting amounts here, right? You will have 5% interest and adding it, and you get $105, right? And then that is for 1 year. After 1 year, you got $5. So in simple interest, next year, you still gonna add $5 if you do simple interest. But because this compound the initial balance with interest after 1 year. So now I have new balance and now I adding with the new interest gonna be 5.25, and I will get $110.25. So this is kind of like really fair way that thinking like, oh, if you borrows from the parents or from the friends in 10 years and with like 5% simple interest, you don't compound, you don't combine the money, the initial money with the interest for each year. You just adding the constantly for 8 years, right? You don't want to change it. So we keep doing that way, right? And end up with 10 year will be 162.89. Okay, 162.89. So let me do that. 162.89. Okay, so if you compare, let's say, if you using simple interest formula in 10 years, we have A equal to P times 1 plus R times T. Okay, A equal to $100 times with 1 plus excuse me, 5% is 0.05 times with T is 10 years. What do you have? Here's the use calculator. I got $150, right? $150. So why? Because you're just adding 5 forever. You're adding I mean you're adding 10 times 5. Like each year, it's just only each year. Each year, you have you just add $5 only, right? And constantly, right? So it's kind of like different with the compound amount, and compound amount make fair, right? Because after 1 year, I don't wanna just stick with $100 at initial. I adding the interest with adding the interest and make the new initial gonna be 105, right? So see, this is this is gonna be look like you are having a exponential function, Okay. So compounds, integers, keep combining the integers the initial amount with integers. In a period of time. So, and now you will have the formula look like this. A will equal to hundreds as the initial amounts, and you multiply by 1 plus 0.05 and raised to power t. Or maybe I say 10. Okay, go down. So if you use this in a calculus, right, you will have like hundreds times 1.05 raised to 10. Okay. And that's, you will get exactly what I have. 162.89. Okay. So this is exactly an exponential function. Okay. The one above here, the simple interest is, this is a linear function. Right? See, it's just at $5 constant, right? It's don't want to change by even though it's still saying like using the rate, right, at 5%, but it's just always using that 5% for the only initial amount, but you don't want to combine it, so that doesn't make an exponential function. Okay, so according to that, we want to make is more general for comparing just as the formula is below here. Yeah, so I have A equal to P times 1 plus R over M raised to power MT. Okay, so people say, what's it? What's M here, right? A is the same as before, which is the amount of future values. P is still a principal or present values. R is still the yearly interest rate, but in decimal. And M will be the numbers compound year, compound periods per year. And lastly, T is duration of loan in years. So I would love to make one row, right? Next row. Make this to be next row with us. But anyway, yeah. You're gonna see right now we have in this form, this one is new. Right, this one's new, the newest one. As M equals to the number of compound periods years. So what does that mean? Last we have an example, and I'm going to show you, right? So first, example 3.19. I say invest 12,000 at annual rate. So yeah, invest 12,000 would mean it is an initial amount or is it future amount? Future amount, right? So I have P on this. Annual rate at 6%. Okay, so I'm gonna have are gonna be 6%. I change to be 0.06. And next one is use even